everyone, this is Midnight Mommy. So for this tutorial, ituturo ko sa inyo ang liquid pressure. So in my previous video, diniscuss ko doon yung tungkol sa pressure. So ngayon naman, ang i-discuss natin is about liquid pressure or ito yung pressure na ini-exert ng isang liquid. So sinasabi natin dito that pressure is directly proportional to the density of the liquid and this is also directly proportional to the height of the liquid column. So kung ilalagay natin sa equation, this one is equal to P is wherein P is your liquid pressure or sometimes tinatawag din natin to na gauge pressure. So this is equal to the density of the liquid times G or the acceleration due to gravity and the height of the liquid column. So pwede rin natin isipin na yung height na to is also equal to your depth. So kung halimbawa, kung kino-consider natin, let's say yung lalim ng tubig, so yung depth na yon is also equal to the height of the liquid column. Yung sinasabi dito based sa equation na yung density ng ating liquid is directly proportional to the liquid pressure. Ibig sabihin, pag mas mataas ang density ng ating liquid, mas mataas din ang ating liquid pressure. So, ganun din sa height. Kapag mas mataas yung height ng ating liquid column, mas mataas din yung value ng ating pressure. So, meron din tayong tinatawag na absolute pressure. Pag sinabi nating absolute pressure, this is the pressure exerted by the liquid in the atmosphere. So, dito, ito rin yung equation ng liquid pressure. Pero idadagdag lang natin yung pressure na exerted na ating atmosphere. So in this case, ang tawag natin dyan is the P sub O or that is the atmospheric pressure na equivalent sa 1.013 times 10 to the 5th pascals. So the pressure of the liquid is the same at any given depth below the surface, regardless of the shape of the container. So ang ibig sabihin lang nito, for example, meron tayo ditong aquarium na merong different shapes. So kahit na iba-iba yung shapes niya, pero dahil iisa lang yung taas ng ating water level dito, okay, iisa lang yung ating height of the liquid column, lahat yan, pare-parehas lang sila na ini-exert na liquid pressure. Kasi ang liquid pressure natin, based nga sa ating equation na rho GH, nakadepende lang to sa height ng ating liquid. Kaya in this case, pare-parehas lang sila ng liquid pressure. What is the total pressure? 5,000 meters below the surface of water. Identify natin yung mga given dito sa ating problem. So meron tayo ditong height ng liquid column na 5,000 meters. Ang tinatanong sa atin is the total pressure. So, since sinatanong ang total pressure, ibig sabihin, kailangan natin itong i-compute muna yung liquid pressure and then i-add natin yun doon sa ating atmospheric pressure. So, we know na ang ating atmospheric pressure is equal to 1.013 times 10 to the 5th pascals. Now, yung ating density ng water, so ang density ng water is a constant. So, although hindi siya binanggit dito sa problem, i-assume na lang natin na yung water natin dito is pure water or fresh water. So, let's assume na this one is 1,000 kilograms per cubic meter. And then, kailangan din natin gamitin dito yung ating acceleration due to gravity na 9.8 meters per second squared. Okay, so sa formula natin ng total pressure, so meron tayong P sub O plus rho GH. Sa substitute natin yung mga values, meron tayong 1.013 times 10 to the 5th pascals plus, okay, ang density ng water is 1,000 kilograms per cubic meter times yung acceleration due to gravity na 9.8 meters per second squared. Okay, and then i-multiply din natin siya sa height na 5,000 meters. Okay. So kapag in-input natin to sa calculator, i-express na lang natin yung final answer in scientific notation. So this one is 4.91 times 10 to the 7th pascals. Okay, so ito pong ating total pressure. A submarine goes 10,000 meters deep into the sea. How much pressure does the salt water exert on the submarine? So the density of salt water is 1,025 kilograms per cubic meter. So given sa problem natin yung height ng ating liquid column which is equal to 10,000 meters. And given din tayo ng density ng salt water na 1,025 kilograms per cubic meter. Okay, so kung i-compute natin ang pressure ang hinahanap natin sa problem na to. So, meron tayong rho GH. Okay, so kung isa-substitute natin yung mga values, so meron tayong 1,025 kilograms per cubic meter times 9.8 meters per second squared times yung ating height ng liquid column na 10,000 meters. So kung i-input po natin yung ating value sa calculator and i-round off natin yung sagot natin into scientific notation. So this one is equal to 1 times 10 to the 8 pascals. So yan po yung ating pressure. Ano po nakatulong ng malaki sa inyo itong video na to. So I'll see you on my next video.